Have you ever felt afraid when alone in silence? When you turn off your phone, there's no music, no one texting, just you with yourself. And that feeling of emptiness makes you want to run away immediately. You're not alone. Millions of people are filling every moment with social media, work, entertainment. Anything to avoid facing nothingness. We fear emptiness like we fear death, because in our minds, nothing equals loss, meaninglessness, non-existence. But what if I told you that modern science has just proven nothing is not empty at all? That in what we call absolute void, there's still an endless dance of energy happening? And more importantly, that understanding this can free you from the greatest fear of human life? The empty box experiment. Let me do a thought experiment with you. Suppose you have a perfect box. You start removing everything inside it. You remove the air, every molecule of oxygen, nitrogen, carbon dioxide. You continue removing every atom, every smallest particle of matter you can imagine. You lower the temperature to absolute zero, minus 273.15 degrees Celsius, where theoretically all atomic motion stops. You isolate the box from all electromagnetic fields, all radiation, all external influences. By conventional logic, now you have a completely empty space, an absolute nothing, pure void. There's nothing there at all. But this is where modern science delivers a shocking discovery. You're wrong. When nothing is still something. Quantum physics tells us something completely different. Even in that empty box, something is still happening. Not the presence of matter in the classical sense, but a sea of energy oscillating, bubbling with constant fluctuations. Imagine a still pond on a windless morning. From a distance, the water's surface appears completely flat and calm, like a mirror. But if you come closer, kneel down, and look carefully, you'll see tiny ripples, microscopic oscillations caused by temperature, by the movement of water molecules, by countless factors. The surface is never truly, completely still. The quantum vacuum is the same, but at a much deeper and stranger level. It's never truly silent. It's always oscillating, always bubbling with energy fluctuations. Pairs of particles and antiparticles continuously emerge from the void, exist for a fleeting moment too brief to measure directly, then annihilate each other and disappear back into nothing. This is what physicists call the quantum vacuum, the lowest possible energy state, but not nothing. It's a state where nothing and something are no longer two clear opposites, but two sides of the same miraculous reality. Evidence from two metal plates. This sounds like science fiction, like an abstract philosophical idea. But it's not just theory. It's been proven experimentally. In 1948, Dutch physicist Hendrik Casimir made a bold prediction. He said that if you place two metal plates parallel very close together in a vacuum, just a few millionths of a meter apart, they would be attracted to each other by a small but measurable force. This force doesn't come from gravity. It's too weak at that distance. It doesn't come from electromagnetism in the conventional sense. The metal plates are electrically neutral. So where does that force come from? From the empty space between them. According to Casimir, in the infinite space outside the two metal plates, all frequencies of quantum oscillations can exist, from long waves to short waves, from slow oscillations to fast oscillations. But in the narrow space between the two plates, only certain frequencies can fit, like only certain musical notes can resonate in a flute. This difference creates a pressure. The pressure from outside is greater than the pressure from inside, and pushes the two metal plates closer together. This is the Casimir effect, and it has been measured many times with high precision. The empty space between two metal plates is acting on them. Irrefutable proof that nothing is not empty at all. 0-point energy, when doing nothing, is still doing something. The concept of 0-point energy goes even further. According to quantum mechanics, every field, electromagnetic field, electron field, quark field, has a minimum energy level even in the unexcited state. Even when there's not a single photon, not a single electron, not a single particle active, the field still has a background energy. This stems from one of the most fundamental principles of quantum physics, Heisenberg's uncertainty principle. This principle states that you cannot simultaneously know precisely both the position and momentum of a particle. The more precisely you know the position, the more uncertain the momentum, and vice versa. Applied to energy and time, this means in extremely short time intervals, energy can fluctuate significantly without violating conservation laws. Energy can be borrowed from the void as long as it's returned quickly enough. This is why particle-antiparticle pairs can emerge from the vacuum. An electron and a positron, the antiparticle of the electron, can suddenly appear, exist for a fleeting moment, then collide and annihilate each other, returning the energy to the vacuum. They're called virtual particles, not because they're not real, but because they exist too briefly to be directly observed. But don't let the word virtual fool you. These particles have real consequences. They contribute to the Casimir effect. They cause the Lamb shift, a small shift in the energy levels of the hydrogen atom that cannot be explained without accounting for vacuum fluctuations. They affect how fundamental particles interact with each other. Nothing is not just a philosophical concept. It's a dynamic, bubbling physical entity full of potential. The paradox of emptiness. This is where science touches philosophy profoundly. If nothing is not truly empty, if it contains the potential of all existence, then where is the boundary between something and nothing? We're used to thinking about existence as a binary state. Something either exists or doesn't exist. A chair is there or not there. A person is alive or dead. An idea exists or doesn't exist. Black or white. 1 or 0. But the quantum vacuum shows us a different picture. A reality where existence and non-existence are not two discrete states, but two poles of a continuous spectrum. A virtual particle exists in that brief moment. But does it really exist in the conventional sense? It can't be directly observed, but it has measurable consequences. So is it something or nothing? The answer is both. Or more precisely, this question no longer makes sense in the quantum framework. Something and nothing are not two opposite states, but two aspects of the same fundamental nature. And this isn't just true for microscopic particles. When physicists try to calculate the total energy of all quantum oscillations in the vacuum, the total energy of all fields, all frequencies, all possible oscillations, they encounter a strange problem. That number tends toward infinity. This is called the vacuum energy problem, and it remains one of the greatest mysteries of theoretical physics. How can an empty space contain infinite energy? And if it contains infinite energy, why don't we see its consequences everywhere? Some scientists believe that dark energy, the mysterious force pushing the universe to expand at an ever-increasing rate, may be related to this vacuum energy. If true, then nothing is not only the foundation of matter, but also the driving force behind the evolution of the entire universe. Let that sink in for a moment. The force pushing galaxies apart, the force shaping the fate of the entire universe, may come from nothing, from emptiness, from what we thought was nothing at all. When fear meets science. Now let's return to the original question. Why are you afraid of silence? Why are you afraid of emptiness? For thousands of years, humans have feared the void. We've tried to fill every gap in space and time in the mind. We viewed nothing as a threat to existence. In many cultures, emptiness is associated with death, with ending, with nothingness. But the quantum vacuum shows us a completely different story. Emptiness is not the enemy of existence. It's the source of it. It's not absence, but the presence of all potential. It's not the death of creation, but its womb. Think about a blank sheet of paper. For someone who fears emptiness, a blank sheet is frightening. There's nothing on it. But for an artist, a blank sheet is full of potential. it can become anything. Every painting, every poem, every piece of music begins with emptiness. And precisely because there is that emptiness, creation can happen. Similarly, think about silence in music. If every moment were filled with sound, there would be no music, only noise. It's the silences between the notes that create melody, create rhythm, create meaning. A beautiful piece of music is not one without silence, but one that knows how to use silence. The quantum vacuum is telling us the same thing about reality. Nothing is not an absence that needs to be desperately filled. It's the necessary space for something to emerge. It's the silence from which sound can resonate. It's the blank canvas on which reality can be painted. Changing perspective, changing life. Perhaps the most profound thing is not the numbers or mathematical formulas, but the shift in perspective. When you understand that nothing is not an enemy, but a companion, something begins to change in how you live. You're no longer afraid of moments of silence. Instead, you begin to cherish them as moments when you can hear the deep voice within yourself, the voice usually drowned out by the noise of life. You no longer feel the need to fill every gap in your schedule. You begin to see the value of periods of doing nothing, not out of laziness, but because that's when new ideas can arise, deep insights can emerge. You're no longer afraid of endings, of a relationship, of a job, of a phase in life. Because you understand that every ending creates a vacuum, an empty space from which something new can begin. This is not abstract philosophical consolation. This is a scientific truth with profound practical consequences. And it opens a door to an even deeper question, the remaining question. But here's the strangest part. More than 2,000 years before Werner Heisenberg stated the uncertainty principle, more than 2,000 years before quantum physicists discovered that the vacuum is not empty, an Indian philosopher named Nagarjuna spoke of an almost identical concept, sunyata, emptiness. He said that everything is empty, but not in the sense of nothingness, but in another sense, a sense that science is now confirming. Is this a coincidence? Or did the enlightened one see what science took 2,000 years to prove? And more importantly, if nothing truly contains all potential as quantum physics has shown, if emptiness is not absence, but fullness as Buddhism has taught, what does that mean for your life? If even the vacuum is bubbling with energy and potential, then could those empty moments in your life, those times when you feel loss, loneliness, not knowing what to do, also be containing a potential you haven't yet seen? Could your fear of emptiness be preventing you from accessing your own greatest source of creative energy? In the next part of this series, I'll show you the astonishing parallels between the quantum vacuum and Buddhist sunyata. You'll understand why emptiness is not negation, but liberation. And you'll discover how this perspective can completely change how you face suffering, change, and yourself. Because when you understand the true nature of nothing, you'll never fear emptiness again. Instead, you'll learn to dance with it and discover that in that dance is where life truly begins. See you in part 2. When Buddhism meets quantum physics, what the Buddha knew 2,500 years ago.